Good morning. I am Gokul from IoT department, fourth year. Today I am going to tell about my main project topic called Tariff A Price Plan Recommendation System. And my team number is 293. I am doing this project under the guidance of my mentor Gisela Mool from the ADS department. Going to my project, there is some agenda called introduction, statement of the problem, scope of the project, methodology. In methodology, there are different kinds of diagrams and what are the algorithms used, and some implementation of the program, and some code segments we are going to see in methodology. And in every project, we have some outputs and result. And at last, we have some test cases which are passed in this project, and we have conclusion and future works and reference. Going to introduction. In today's competitive telecom and service-based industries, customers are offered multiple tariff and subscription plan with varying prices, features, and usage limits. Yeah, what is service-based industries? It is also called as like business-based level industries, where we can see some application through website, like for example Netflix. Netflix is one of the application where we can use for seeing movies, series with the subscription. With only when we subscribe, we can see all the things. So we have various subscription for mobile, for laptop users, and some PC users, PC with mobile. We have various subscription for a monthly pack or yearly pack. So we have suitable plans for complexity and volume of available options. Artificial intelligence and machine learning provide an effective solution by analyzing customer usage behavior and recommending optimal tariff plans. It is also a business efficiency where we can use some sort of data driven techniques to improve our customer satisfaction. In the statement of the problem tells it is a technical knowledge required to analyze tariff plans and analyze them and match them with their actual usage. Traditional recommendation approach are rule based and fail to adapt dynamic customer behavior. Yeah. The problem addressed by this project is the absence of an intelligent automated system that recommends optimal price plans based on a real customer data. This is the statement of the project, and we have some different kinds of scope: functional scope and technical scope. What is functional scope? The system analyzes customers usage data such as call duration, data consumption, SMS usage, and monthly expenses. Yeah, I have already told we have some kinds of data driven mode in our mobile and PC. It customized some of the duration and data consumption and SMS, where we can spend some extra. If you want extra data, we can spend some sort of money to extend the storage with unusual expenses. Based on these parameters, it recommends more suitable tariff plans. In that also we have some plans which is very useful for our recommendation usage. Yeah, coming to technical scope, the project uses machine learning algorithm for classification and recommendation. For classification and recommendation, we are using some sort of data pre-processing, feature extraction, model training, and evaluation core components. We are implemented with the in these projects by the system of Python and common ML libraries. We integrated using API based deployment, enabled real time recommendations. And the project can be used by telecom companies, subscription based services, and enterprise pricing platform. It supports data visualization dashboards to display usage trend and plan comparison, both for users and administrators. Yeah, coming to methodology, there is some of the data which is collection and pre-processed data which have been used in methodology. Data collection. Customer usage data is collected from historical records, including call duration, data usage, SMS count, and monthly billing details. This kind of details will be under data collection. The billing and the amount selling, how much it have priced, and how much duration it has been recorded. It all comes under data collection. And data privacy and anonymous are maintained to protect customer information. Coming to data pre-processing. The collected data is cleaned to remove missing values. All the collected data from the data collection are cleaned to remove missing values and duplicates and outliers. Normalization and scaling are applied to ensure uniform feature ranges. Pre-processed data is split into training and testing dataset for model evaluation. The pre-processed data it will be split into training and testing. It goes for training and testing dataset for model evaluation. This is the architecture diagram and the design which I've used for use case and class diagram. A use case is a graph or set actors of use cases enclosed by a system boundary. Communication and association between the actors and the usage. Where actors act as a administrator and user as a customer. This is the use diagram. Design use diagram. The admin and the product users and system users. And this is the design class diagram. A class is representative of an object, and in many ways it is simply is a template from which object is created. This is a class object. This is a sequence diagram where you can use a website, product page, shopping, etc. etc. The payment method, payment page, order review, and order confirmation. It's an example for e-commerce site. And in every machine learning algorithm, we have a malware detection where user can detect various type of data management module and database. Sequence A product guide, actor, chatbot, ST algorithm database. Yeah, algorithm used. Algorithm coming to the algorithm. Supervised machine learning algorithm are used for tariff accommodation. Decision tree and forest algorithm are preferred due to their interoperability and accuracy. These algorithms classify customers into suitable tariff categories based on the usage phases. The algorithm selection depends on data size and performance requirements. Yeah, working principle. The algorithm learns from labeled training dataset and usage perform is associated with an optimal tariff plan. This ensures personalized recommendation. Random forest improves accuracy by combining multiple trees, reducing overfitting and handles large dataset efficiently. A hardware and software selection. The tariff AI plan is a software centric application does not require any specialized hardware. It consumes like Intel Core i5, 8 GB RAM, and 256 SSD, sufficient with an Intel Core i5 with the data processing. Yeah, in software selection, the system is developed using Python due to its simplicity, flexibility, and strong support for machine learning applications. Yeah, NumPy and Pandas are used for data processing, while Skitlearn is employed as for implementing machine learning algorithms like random forest and decision tree. Yeah, this is the implementation. The tech stack of the implementation. The project is implemented using Python libraries such as NumPy, Pandas, Sklearn, and Matplotlib are used. And Flask and Streamlit can be used for interface. Data is stored in CSV file or relational database. The system is lightweight and cost effective. These are the sample code. The code trains and models predict the best tariff plan for a user. Implemented highlights. The implementation is efficient and user friendly. Yeah, these are the code segments we have used for the tariff A. This is output example of the output. These are the test cases which have passed. User registration, user login, image upload, and some kind of yeah. There is a result conclusion. In conclusion, the tariff AI system successfully recommends optimal price using machine learning. It addresses key challenges in tariff selection. In key